finish this, watch. Huh?
After finish this one.
You have to watch more of the video. What? Nothing. Did Marcelo send you a message? Did he? Oh, he didn't send you a message. I said to the business students, we can get Chinese food tomorrow.
My Chinese friends said they want my WhatsApp number.
Yes?
But nobody asked me.
Yeah.
And I don't know who is he or she.
He.
He.
Yeah. He's Brazilian student. No, the other guy.
Sean?
Yeah.
Yeah, I know.
You know him.
Talk to him. 5 words.
Just 5 words?
Yeah. I agree with you. 4.
Okay. Can you move this to the right, please, Grace? A little to the right. Thank you. Okay. No, that's perfect. No. No. You said 10,000 has buffets.
Yes.
So they can do like a tray of food.
What do you trade?
Like a tray. You know?
Tray?
Tray of food.
Takeaway? Or?
Like this, and then you have lots of
Yeah.
chicken wings or something. They do this, yeah? How much do you think money
For
to get food?
maybe less than 10.
That's for you.
Yeah,
Just
me
for
only.
you.
Yeah, for
Yes.
me only.
Well, for everybody.
I'm poor now.
Yes. No, I know that. I just need to know how much. Do you have a menu?
Do you go to Jimmy Trump's or
Yes.
the same one?
Okay.
Hello.
Hey,
Aaron.
you're late because you were getting sausages, croissants.
Similar as Jimmy Trump, but less food.
But they do takeaway.
Yes. They do take away 5.99 per person, I think.
$5.99 per person.
I think it's in the country.
Okay. And what do you get for $5.99? You get good food?
I think it's good.
You get lots of food
As much as you can put in that box.
for $5.99?
Yeah.
And they do takeaway.
Yeah. Just if you go there to eat it per person is 9.99 because the name is cancelled.
Okay.
And they can take away food.
$5.99.
Yeah.
Great. That's great. Okay.
But I don't know which person like which kind of.
We'll find out today. Okay. Have you got the physics exam? Sophie, do you have yours? Yeah, okay. And Hareen, you got the physics exam? Are we on B5? Is it?
Yeah.
Okay, can you read the first part, please?
In the end of the diagram, briefly explain an explanation that could be used to determine the critical angle of glass.
Ah,
The light box.
the light box, yeah. You did this experiment, except instead of water,
Which type? Which topic?
Snell's law. But no, wait, look, you remember doing this experiment? Yeah, so what you need to do, and then here's the laser. Yeah, and this is the eye, and this is the OR. So you increase I until R equals 90. This is the critical angle. This is the light box. This is the glass. That's the laser. This here can be air. Yeah, something like this. How many marks is it? Maybe I need to give a sentence. But you remember this experiment. It's the one that you did. Except the only difference is they use glass instead of water.
But how do you put the glass in the light box?
Instead of the bottom half being filled with water, you put like a half circle shape of glass in it.
Can you do that?
Well, there were some glass pieces that came with the light box, the much smaller ones. I think you could do it some way. Huh?
They are up for glass.
No, this is like the light box, but instead of water in the bottom, there's glass. But there's another way. If you don't like that, that's fine. You could do it like this. Look, you have some paper. And on the paper you put ugly. You put some glass on the paper, and then what you do is you get a laser and you shine the laser through and it comes out, and then you take a pencil and you mark with a pencil the laser, and then you take the page away, and then you have your page, and on your page you'd have two pencil lines like this, and then you can measure the angles later, and then you can use this to get the N1 and the N2, like what you did in the experiment. And you know that sine I over sine R equals N2 over N1, so you can use this to get the I, the critical angle. So this, whatever way you want to describe it. What's next? Where do you get that croissant? It looks delicious. Where? The cafe does? Like the canteen? No, it's okay. I'm not that desperate.
Yeah, the canteen.
What's next?
The critical angle for a glass block in air is 41.81 degrees. Determine the refractive index of the glass.
Right, and N1 is air. They want N2. This is index.
Usually, the air is the one.
Sine I over sine R equals N2 over N1. Wait, no, sorry. I have that the wrong way. It's not going from air to water, it's going from water to air. Yeah, sorry, glass to air. So the N2 is 1.
How do you know it's from glass to air?
You don't, well, you just figure it out soon enough because you won't get an answer the other way. Critical angles only happen when you go from the denser material to the less dense material. Yeah. 41.81, is it?
Yeah.
Okay, what's next? What part is this? Part 3?
Yeah.
Yeah, what's next? So,
If the glass block was placed underwater, determine the critical angle.
Okay, alright. So this time now you have some water and you have some glass. Does it say what the index for water is?
Yeah.
What?
This index of water is 1.33.
Okay, so the water is 1.33 and the glass is 1.5. So now it goes like this. But it's still the same deal. Sine I over sine R equals N2 over N1. Okay, what's next? Part 4? B.
In a young substitute experiment, light of wavelength 438 nanometers is used
438 nanometers.
is used to illuminate the narrow double slits, which are 3.35 times 10 to the negative 4 meters.
3.35 times 10 to the minus 4 meters apart.
If the distance between the double slit and the screen is 0.915 meters, determine the distance between the bright fringes seen on the screen.
So they want this distance here, which we call it X, but I think in the formula book they call it something else, don't they? Call it S, I think. Isn't it?
We call it epsilon.
Yeah, we can. S.
I didn't find.
Did you find the formula?
Oh, okay.
Yeah, it says lambda equals
No,
Oh, x over d.
XS over big D.
Fringe width x.
Fringe width is X. Okay.
Slit the screen distance d.
Just so you know, in the formula book they write it like this: lambda equals XS over D. But for me, it's lambda equals DS over D. I just use D instead of X.
Yes.
So you're right, excellent.
Oh my goodness, I'm an idiot. Thank you. X. For me, lambda equals XD over D. In the formula book, they write lambda equals XS over D. They use S for this one. This is because that's what my physics teacher used and it stuck in my brain. Anyways, I'll tell you how I remember the formula. This is how I remember it in my head. Wavelength equals small multiply small over big. Because this is the big distance and this are the small distances. So this is how I remember it. You multiply the small distances and you divide by the big distance. So that will be 3.35 times 10 to the minus 4 times x all over 0.915. But we know what the lambda is. So I get x equals 1.196 millimeters. That was actually straightforward. Is there another part to it?
Yeah.
This is like part 1.
Yes.
Okay. Is part 2 about getting an angle?
The screen is so further away from the double slit,
Yeah.
and the distance measured across 30 fringes is 40.6 millimeters.
Oh, I see. So in part 2, they this now is, what is it, 40 point? Yeah, millimeters.
Yes.
Yeah.
Determine the distance that the screen has been moved.
Ah, easy peasy. It's the same formula again. So you have lambda, which is, what do we say? 438.
Yeah.
So 438 times 10 to the minus 9.
We can use nanometer.
Yeah, 10 to the minus 9. Yeah. Equals 40.6 times 10 to the minus 3. And then the 3.35 times 10 to the minus 4. So this time we just want the D. Crunch. So the D, oh, it's huge. Okay. The D is 31.05 meters. Which means it was moved 30.14 meters. They want to know how far it was moved. So what's happened is they've moved the screen further.
Minus 0.
Yeah. Is there more?
In such an interference experiment, it is important to ensure that the light from the double slit is coherent. Explain the term coherent.
Oh, well, we know this one. What is it?
Same period, same wavelength.
Light that is in phase. So you said, what did you say? You want same frequency.
Same period, same wavelength.
And constant phase difference, isn't it? I think so. Which means that basically your two light waves, really you want them to be like this, that they have the same frequency and that they are in phase. And normally the phase difference is 0, so that they match up perfectly, peak with peak, trough with trough. Although this is not something that has to be true. And again, no, it doesn't matter. What's next?
And D.
Yeah.
A diffraction grating has 800 lines
Yeah.
milli per millimeter.
800 lines per millimeter. Yeah.
A ray of light of wavelength 438 nanometer is incident normally on the grating surface.
Yeah.
Determine the spacing of the line rules on the grating.
Okay, so if it's 800 lines per millimeter, then the distance will be 1 over 800 millimeters.
How do you change it to units on the calculator?
Well, no, I wouldn't do it like that. I think about it like this. You have 800 lines per millimeter. And that means you would have 800,000 lines per meter. So that means you would have 1.25 times 10 to the minus 6 meters is the distance between the lines. So for example, if I said you had 2 lines per meter, then they're half a meter apart. If you have 3 lines per meter, then they're a third of a meter apart. If you have 4 lines per meter, then they're a quarter of a meter apart. So all I do to get this number is just calculate 1 over 800,000 to get that. What's next?
What's the formula for
Here? No formula, I did this. Grace, if I said I had 2 per meter, so here's 1 meter, and I had 2 per meter, then the D would be 0.5. Yeah? Okay. Right, what's next?
Determine the angle of diffraction for the second order structural line.
So n equals 2, D is 1.25, and lambda, what did we say it was? 438?
Yes. Lambda.
So we have n lambda equals d sine theta. So theta equals sine inverse n lambda over d. (44.5 degrees). Anything else?
Yeah, one more.
One more, okay.
Know that this is the maximum order of diffraction that is observable.
Great, okay, so for maximum you have n is you don't know, lambda is still the same.
The angle less than 90, right?
Yeah, that the theta is less than or equal to 90. So we'll make it equal to 90 to get the maximum. So we have n lambda, oh, and the d is the same. What did we say the d was? 1.25, was it? Yeah. N lambda equals d sine 90. So sine 90 is gone. So we'll just divide by lambda. So that's gone as well. So d divided by lambda. D divided by lambda.
how do you cancel them?
I just divide lambda under, sorry, that's the lambda. And here you get n equals 2.85, but really what you're saying is n maximum equals 2.85. So the n must be less than or equal to 2.85.
Sorry, 2 only, right?
Yeah, so the n, the most it can really be is 2. It can't be 3 because then that's too big. What do you think of the physics exam? That's what you think of it, okay. Andy? Yeah, what? What do you think of the physics exam? Yes, this one. I know, but your opinion, how do you feel about it?
After you said it,
Yeah. That's my job. Yeah. Yes. What do you think of the physics exam? Will you review enough? Wait, so hang on. About what?
The Moodle.
Moodle?